Hello, my name is Carla Curran, and I will be doing my presentation on young adult nutrition during exercise. So, to kind of introduce my topic, what nutritional changes are seen in young adults during exercise? Well, exercise causes several physiological changes that will alter the nutritional needs of the individual. Exercise requires excess glucose and ATP, as well as an increase in fatty acid use and an increased protein breakdown. So it's important to understand the changes that happen in the body during exercise in order to properly fuel your body. So that's what I will be touching on today during my presentation. So let's go ahead and dive right in. What nutritional changes occur during exercise? So when you exercise, it causes hormonal changes in addition to an increased demand for glucose and ATP. So exercise increases epinephrine, cortisol, and growth hormone inside the body. And together, these hormones initiate the release of glucose and fatty acids into the bloodstream. So most glucose and fatty acids are taken up by the skeletal muscle for energy. So when you exercise, there's that increased demand. So that demand is replaced. And then the remaining is taken up by the brain and the red blood cells. So how does this all happen? Well, muscles require ATP in order to function. And how much ATP will depend on the duration and the intensity of the exercise. So there's three different energy systems that skeletal muscle uses in order to produce and supply ATP. The first is known as the phosphocreatine system. The second is the lactic acid system, otherwise known as the anaerobic glycolysis. And the third is the oxidative system, which is also known as aerobic metabolism. So to address the topic of when do the different energy systems function, at the beginning of exercise, the energy needs are met by existing ATP, what's already in your body. As ATP decreases, it's replaced by the rapid phosphocreatine system. So that's the first system to kick in. After about 15 to 20 seconds, the lactic acid system kicks in and helps out. And then finally, the oxidative system is the main supplier of ATP for exercise lasting longer than 2 to 3 minutes. So first phosphocreatine, then lactic acid, and then oxidative in that order. So again, to kind of address the timing, when do these different changes happen? High intensity and short duration exercises like sprinting, for example, that's going to use both the phosphocreatine and lactic acid systems. And the lactic acid system, which involves the glycolytic pathway, that's used for short-term exercise lasting 1 to 2 minutes. So a little bit longer, but still kind of in that short range. And then finally, the oxidative system, which is also called aerobic respiration, that uses the TCA cycle to break down glucose and fatty acids and some amino acids. And this is used with endurance exercise, so especially like marathon runners. And then to address each nutrient specifically, I'm going to touch on the three different macronutrients, the first being glycogen or glucose in the muscles. So what effect does exercise have on glycogen? Muscle glycogen is important for high intensity exercise, especially. So like high intensity interval training, sprinting, things like that. Low levels of muscle glycogen attribute to fatigue. And muscle glycogen depletion varies widely among individuals. So there's no blanket number you can throw out there. It's going to be different for everyone. And studies have shown that muscle glycogen depletes 30 to 40% after resistance exercise. So it does deplete quite a bit, especially after resistance training. And then to address the next macronutrient, fatty acids, moderate aerobic, so not resistance training, more of the aerobic or cardiovascular exercise, ranging from about 40 to 65% of your VO2 max and lasting longer than 20 to 30 minutes. That's going to use more free fatty acids than glycogen. Once you get back up into the 80% of your VO2 max, or the maximum amount of oxygen that you can use, then you're going to start using energy from carbohydrates again. So anything over that 50% VO2 max, that's when you're going to start leaning back to using muscle glycogen instead of fatty acids. So when you get up into those high intensity ranges, it's difficult for free fatty acids to be released from adipose tissue due to that decreased blood flow. And then there's also mechanisms within the skeletal muscle that limit fatty acid oxidation. So again, that's when you get up into those high ranges, you're going to go back to using glycogen instead of fatty acids. And why is protein intake important? So the final macronutrient, resistance training especially, stimulates protein synthesis, but it also stimulates protein breakdown. So the balance between these two, it determines your body's anabolic response, or the muscle's response to resistance exercise. So ingesting an amino acid with or without a carbohydrate directly after exercise is going to stimulate that protein synthesis. And then you should also look to ingest carbohydrates immediately after, because that also aids in protein synthesis and decreases protein breakdown. So how should you time your nutrients around exercise? Prior to exercise, you should have a small meal or snack that's low in fat and fiber so that it's easily digestible, and then relatively high in carbohydrates as well as moderate in protein so that you can have that energy and prevent that protein breakdown throughout your exercise. And then nutrient timing following exercise, that's going to improve your protein synthesis as well as your mood. So consuming a carbohydrate during exercise, or especially resistance training, has been shown to prevent protein muscle breakdown and increase performance. So that's also recommended. And then consuming a protein and a carbohydrate immediately following training has been shown to support increases in strength and improvements in body composition. So again, make sure you get those nutrients in after you exercise. And then it's recommended to consume about 20 to 40 grams of protein every 3 to 4 hours. That's just been shown to have the greatest effect on muscle protein synthesis. So how do nutrient needs change based on the individual? So the amount of carbohydrates needed prior to exercise, that's going to vary based on the individual's daily expenditure, the type of exercise, the sex of the individual, environmental conditions. So a number of different things are going to vary. So again, there's no blanket number you can throw out there because it's going to be different for everyone. Protein intake should be slightly higher than the RDA at about 1.2 to 1.7 grams per kilogram of body weight, and that's in order to increase performance. And high-fat diets are not recommended for those participating in regular exercise. And then in addition, dehydration should be avoided by consuming water before, during, and after exercise. And that's going to increase your performance as well. So in conclusion, both aerobic and resistance exercise requires excess energy expenditure, usually in the form of glycogen or ATP. So for exercise lasting longer than 30 minutes, fatty acids are used in addition to glucose for energy. And then skeletal muscles are broken down during exercise, causing protein degradation, which requires an increase in protein intake for recovery. So individuals participating in regular exercise should consume a diet with an adequate carbohydrate intake, moderate protein, and a moderate intake of fat. Thank you so much.